We welcome you all. We are Department of Mechanical Engineering, Government College of Engineering, Bodi Naikanu. We are going to present a topic on air conditioning system and load estimation, prepared by Professor M. Balamurugan, team head, and team members are Professor M. Sabha Karthik and Professor M. Vinod Kumar. So this is the syllabus of the 5th unit of refrigeration and air conditioning system. In this unit, we are going to study the design perspective of refrigerator system, going to calculate the cooling load for given confined space, and also study the human comfort and IAQ principles, effective temperature and sorts, and calculate the summer and winter air conditioning loads, and also study the air conditioning system with controls, pressure, temperature, humidity sensors, actuator and safety controls. Cooling load. So we are going to define the what is cooling load. The total heat required to be removed from the space in order to bring it at the desired temperature by the air conditioning and refrigeration equipment is known as cooling load. The purpose of a cooling load estimation is to determine the size of the air conditioning and the refrigeration equipment to give desired temperature or to maintain the desired temperature of the confined space. Next, the components of a cooling load. First one is the sensible heat. That means there is a direct addition of heat to the enclosed space. The reason here is the heat flow into the building by conduction through the exterior walls, floors, ceiling, door and windows, and heat absorbed by the wall and roof exposed to the solar radiation. The third one is the heat given by the lights, motor, machinery and cooking operations inside the confined space. The last one is the heat liberated by the occupants in the confined space. Latent heat gain. That means there is an addition of water vapor to the air of enclosed space. The reason here is the heat gained due to moisture in the outside air entering by the infiltration. The next one is the heat gained due to condensation of moisture from the occupants. The total load is equal to sensible load and latent load. Here, the first one is the sensible heat gain through building structure by conduction. It's like a normal convection problem. So consider a building wall composed of a single homogeneous material. A little consideration will show that heat passing through the wall is first received at the wall surface, that is exposed to the region of higher temperature by radiation and conduction. Then the heat flow through the material of the wall to the surface exposed at the region of lower temperature. Now the heat is transferred to the inner side of the wall to the space. This is the simplest one. The next one is a building wall composed of composite wall. The thickness of wall is higher. It made up of different materials. It's also exposed to the high temperature on one side, lower temperature on other side. The heat transfers from the high temperature side to low temperature side through the conduction mode. So this is the example of composite wall. Composite wall made of three different materials. The material name is A, B, C. So T1 is the highest temperature, T4 is the lowest temperature. The heat transfer from left side to right side through the conduction mode. In some case, we consider the high temperature air and the low temperature air to calculate the amount of heat transferred to the space. Here Q equal to the amount of heat transferred through the wall. Q equal to U del T. So U means overall heat transfer coefficient, del T temperature difference. So 1 by U equal to resistance of the composite wall. This is the formula F naught, heat transfer coefficient of outer, Fy, heat transfer coefficient of the inner, and the conduction resistance. The heat gained from solar radiation, that means irradiation. The solar radiation striking the outside surface of a building may be contributed appreciably to the peak load on the refrigeration and air conditioning equipment. Therefore, we consider the solar irradiation strike on the outside wall of the confined space. This solar radiation depends upon the following factor: altitude, angle of the sun. It also depends upon the altitude, angle of the sun, and the clearness of the sky, absorptivity of the surface of the wall, and portion of the surface exposed to the sun. The next one is the heat gain due to infiltration. The infiltration means infiltration is the air that enters a confined conditioned space through the window cracks and opening of the doors. There is the crack and opening in the windows and doors. Due to this opening, the air pressure difference, the air enter from outside to inside of the conditioned space. This is the reason is the pressure difference on two sides of the window and doors, and also it depend upon the wind velocity and its direction, and also difference in density due to the temperature difference between the inside and outside air. Next, the heat gain due to ventilation. So ventilation is provided to the conditioned space in order to minimize the odor, concentration of the smoke level, to decrease the carbon dioxide level and other desirable and undesirable gases, so that freshness of the air could be maintained. The quantity of the air used for ventilation should be provided at least 1/2 of the air per hour in building with normal shielding heights. Next, the heat gain through the ducts. The heat gain due to supply duct depend upon the temperature of the air inside the duct and the temperature of the air surrounding the duct. We can calculate the heat gain through the duct by using the relation Q equal to UA TA minus TS. So use the overall heat transfer coefficient of the duct, AD surface area of the duct, TA ambient temperature of the air, TS temperature of the supply air inside the duct. Heat gain from lighting elements. It means there is in a conditioned space there is a lot of lightings and a fan. We fitted a fan and a motor and a cooking equipment. There is also release the heat. We are going to account that heat. Mathematically, the heat gained from the electrical light is given by Q equal to total wattage of lights and use factor and allowances factor. Next, the heat gained from the power equipments. So power equipments means like the fan, motor, other equipment of this type also add heat to the air in the conditioned space. The heat gained from the electrical motor is given by Q equal to power rating of the motor times load factor divided by the motor efficiency. The load factor is the fraction of the total load at which motor is working. Next, the heat gained from occupants. In a conditioned space, it is used to give human comfort. So the human body also release the heat continuously. In order to maintain the human comfort of the body, we continuously remove the heat from the conditioned space. So we are going to account the amount of heat released from the each occupant. So here the human body in a cooled space constitutes the cooling load of the sensible heat and latent heat. And the heat gained from occupant is based on average number of people that are expected to be present in the conditioned space. Okay, thank you. So this is the cooling load calculation. We consider all the factors: amount of heat conduction through the wall, and in amount of heat added to infiltration, ventilation, lighting equipments, and other power equipments and occupants. These all the factors release the heat in the confined space. So the temperature of the confined conditioned space is increased continuously. We are going to maintain the desired temperature. We must remove all the temperature, all the heat from the conditioned space. So we are going to calculate the cooling load mathematically and select the suitable refrigeration and air conditioning system for the space to maintain the desired condition. Thank you.